Morning, everyone. Congestion on the road, in the air, or in front of a railway station is waste. Time is lost, infrastructure throughput goes down, and there's a lot of unnecessary pollution. Digitization, big data, can greatly reduce this waste. Successful examples show that. But progress towards it is very slow, too slow. So why is that, and what can we collectively do about it? In fact, infrastructure congestion is a significant burden on society. In Europe, for instance, it's estimated at 1% of GDP and growing. Think of commuters in London or Brussels that waste more than 80 hours in road congestion annually. That's more than 2 full work weeks. Or think of the US, where there are 1.5 million hours of airport delays summing up at a cost of at least 6 billion to society. Or think about our McKinsey Global Institute report on infrastructure productivity from last year that concluded that 15% of global spend on infrastructure could actually be saved if we managed to make more of existing infrastructure. $400 billion per annum. The solution to most of these challenges is in digitization, and examples show that. Let's talk about Israel. Briefly talked about it yesterday. Israel introduced a fast lane between Ben Gurion International Airport and Tel Aviv, a 13-mile stretch, where the tolling system for the fast lane is dynamically linked to the current traffic situation. So if there is a lot of congestion, the fast lane becomes expensive. If there's none, it doesn't cost anything. That's not just a great way of course, yield manage a toll road. It's actually also a good way to steer demand and to make sure that speed patterns align and you have no turbulent flows, creating a lot less congestion. Or let's look at Brazil here. Brazil is faced with a significant airspace congestion issue. Since 2000, passengers have grown by a factor of 4 to more than 150 million, and they're expected to grow again by a factor of 2 until 2030 to more than 300 million passengers. Infrastructure has not been prepared for that. DECEA, the air traffic control agency here in Brazil, is now introducing a navigation system that uses GPS data to dynamically optimize the path of planes. So you don't have planes lining up for hundreds of miles in the end before they actually reach the airport, but you can actually curve in based on GPS data and avoid a lot of detours in the process. Pilots in Brasilia and here in Rio have shown that you save something like 7.5 million of flight time on average on those approaches. That adds up to 1 plane for every 80 landings. It's of course saving a lot of fuel, and it's reducing a lot of the air congestion that's taking place. Or let's look back to Europe. The conventional way of scheduling a railway system is by essentially asking all the railway operators for their detailed requirements on the trains they want to operate, and then the network integrator tries to make it all meet and comes up with an even more integrated and complex plan. Now, if you know that, for instance, in Germany, 81% of cargo trains are just not operating at the scheduled time, but some other, it's obvious that there's a lot of waste in this process, and there's a lot of rigidity in it that makes it very difficult to catch up on delays and keep the system stable. That's why increasingly railways in Europe move towards a slot-based approach, where they split up track capacity into slots of different speed profiles, and then afterwards slot trains against it. And they don't do that only on the planning stage, but they use it also then for steering to make sure that there's a more structured catch-up in case of delays, so you can still arrive at the desired arrival times. From my experience, that can also lead to capacity improvements of something of the order of 10%. All of these great examples, but unfortunately, the progress of rolling out these big data approaches across the transport industry has been more than slow. I mean, from meetings in industry gatherings, for instance, for airports, I mean, there's always great enthusiasm about using big data passenger flow optimization methodologies, but if you look into it, in the end around the world, there are at best a few dozen airports that do anything in that direction. It can't be for economic reasons that this is not happening, because typically the return on investment of this kind of smart infrastructure investments are by a factor of 5 or more effective than investing into similar hardware traditional infrastructure. For instance, if you think about such a slot-based system here, deploying that for a large railway costs about 100 million, probably in IT costs and change management costs, but it has impact in the billion-euro range. So this cannot be the reason. So talking to industry practitioners, what we came up with is essentially 3 major elements that's holding off a broader adoption of digitization. The first is lack of transparency. Transportation systems are usually rather complex ecosystems with lots of players that are interdependent. Think of an airport, right? There are lots of airlines, there are ground handling companies, there's customs, there's border control, air traffic control, retailers, and of course, the airport operating company with its subcontractors. Very complex system, everyone holds data, and everyone holds onto its data because you don't know what happens with it, and maybe it's to your detriment if you pass them on. And that leads to the second challenge here, inequitable sharing. Goals are not necessarily aligned. If you keep again the airport example, obviously a retailer wants to have passengers spend a lot of time in retail. An airline rather wants to have passengers spend time at the gate so they can board properly and transfer fast. And the border control or security obviously wants to have as much time as it takes to be safe. Yeah? So goals are not really aligned. And getting this right is a challenge. And then, of course, infrastructures are natural monopolies normally. So, I mean, there's a lot of regulation around it. And the regulator also has to be convinced of the benefits of digitization. So, where do we stand? This is rather complex. We've seen that digitization represents a massive opportunity to boost infrastructure utilization. And we have the cases that prove that this is the case. But despite of these successes and attractive economic returns, I mean, these barriers here have to be overcome. And this will only work if there's a shaping force behind it. And there are, of course, a few options how these shaping forces could look like. They are the classic ones, right? It's government, which obviously should have an interest in making sure that infrastructure utilization is at its maximum. It could also be the main concession holder in such an infrastructure ecosystem, which probably still needs some facilitation by a neutral party because the trust in these kind of systems is usually not very well developed. What's most likely necessary is that both happens. So from the side of governments, the right boundary conditions must be put in place. It must be clear what's the rule of the game in terms of data usage and data collection. And most importantly, also for the government agencies that are involved in these ecosystems, clear service levels need to be defined. And then it can be on the concession holder to optimize the system, to start the change management process and make sure that win-win solutions come out of that. Now, frankly speaking, these journeys that we are crafting here that I try to describe are also still at McKinsey and R&D state. But we have a couple of examples with airports where we're actually making significant progress. And what we see is that there is a lot more win-win situations that can be crafted in these situations than people would normally think. So it would be great if we here as a global infrastructure initiative would find ways to come up with a couple of lighthouse cases to show how this works and to make the path free here for a broader rollout of digitization for the benefit of all of us. Thank you very much.